here is a question about how the model of the atom changed after Rutherford did an experiment with some alpha particles and some gold leaf. So about early 20th century, fired a beam of alpha particles at gold leaf, and it shows the results. And what we can see from this is that our alpha particles went into the gold leaf, all traveling in pretty much the same direction, but some of them went through, and some of them, well, went through and got deflected, and very few of them actually bounced back. And this is a key experiment, really, for how our idea of what the atom is like changed. So the question's asking us to explain how the results of the experiment support the nuclear model of the atom. So we're going to have to explain, and explanation's got to say how it links to this idea of the atom having a nucleus. That's what it means by the nuclear model of the atom, is the atom with a nucleus. So we can talk about what Rutherford expected and how what they got was different and how that had to change. So what they expected was that if your alpha particles were going through the gold leaf, the vast majority of them would just go straight through, and there might be a little bit of deflection, but not much. Okay, and that was J.J. Thomson's idea of what we call the plum pudding model of the atom. Okay, and it's a bit like taking a machine gun and firing it at some cardboard boxes that you think are full of tissue paper, and those bullets you expect to go straight through because they're cardboard boxes full of tissue paper. So what did Rutherford find? He found that most of the particles still went straight through, and that's because the atom is mostly empty space, but one or two of the particles for every few thousand, a few of them ricocheted back. And that was like firing your machine gun at the cardboard boxes and finding one or two bullets ricocheted back towards you. At which point you might think, well, hang on a minute, there's not tissue paper in those boxes, there's something else going on. And what was going on with the atom was that instead of this idea of them just being round with everything uniformly mixed in a sort of similar sort of density, a similar thickness, actually what was going on was mostly empty space, but these tough, very dense nuclei in the middle of the atom. Okay, and so actually answering the question, how do we say how the results show this nuclear model? The results were that most of the alpha particles went straight through. What does that show? It shows most of the atom is empty space. But what were the other results? Some alpha particles ricocheted off at odd angles, and some of those particles bounced back. What does that show? That shows that there must be a much more dense and small nucleus in the middle of the atom. Okay, so that's your sort of 3 marks for that. 1, talk about what they expected, but really the 3 marks are for saying most of the alpha particles went through. And again, if you're answering this, I would certainly draw diagrams. Most of the particles went through, shows that the atom is mostly empty space. A few of them, well, few of them got deflected, and very few of them got deflected a lot. And that shows you that a lot more of the mass of the atom must be in a very tough, dense nucleus in the middle. Okay.